Alright, so in this video, I'm going to be solving the problem 40 to the power of 40 over 20 to the power of 20. So, for my solution, what I'm first going to do is rewrite 40 to the power of 40 as 40 to the power of 20 plus 20. So now I have 40 to the power of 20 plus 20 over 20 to the power of 20. And now I can use the property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So I'm going to be using this property on 40 to the power of 20 plus 20, so then that turns into 40 to the power of 20 times 40 to the power of 20 over 20 to the power of 20. Now from here, I can rearrange this to be 40 to the power of 20 times 40 to the power of 20 over 20 to the power of 20. And if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So in this case, I have 40 to the power of 20 over 20 to the power of 20. And that's going to turn into 40 over 20 to the power of 20. Now, 40 divided by 20 is 2. So I get 40 to the power of 20 times 2 to the power of 20. Now, if I have something in the form a to the power of m times b to the power of m, this is equal to a times b to the power of m. And this is my third and final property for this video. So in this case, a is 40 and b is 2. So this turns into 40 times 2 to the power of 20, which is equal to 80 to the power of 20. So this is my answer to this problem. Please make sure to leave a like and subscribe and watch another video on my channel. Bye. Alright, so in this video, I'm going to be teaching you guys how to solve the equation 1 to the power of x is equal to 2. Now, I know what you may be thinking. 1 to the power of any number is itself 1. So how can 1 to the power of a number equal 2? Well, there is a method to solving this. So first off, let's take the natural log or ln on both sides. So I'm going to do ln 1 to the power of x is equal to ln 2. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this can equal b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front, so I get x times ln 1 is equal to ln 2. Now, ln of 1 is equal to 0. So I get x times 0 is equal to ln 2, meaning 0 is equal to ln 2. However, ln 2 is equal to 0.693, so this is false. So this method does not work, the usual method of solving exponential equations. Now what I'm going to do is use an important formula known as Euler's formula. So this formula states that if I have something in the form e to the power of I times theta. This is equal to cosine of theta plus I times sine of theta. And I know this may seem a little confusing right now, but let's walk through it. So what if theta is equal to 0? Then this means that I got e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. And cosine of 0 is equal to 1, and sine of 0 equal to 0. So I get theta is equal to 2k pi. Now, if this is true, then e to the power of I times 2k pi is equal to 1. So, because this statement is true, then doesn't this mean that our original equation was 1 to the power of x equals 2. And this is equal to 1. This number right here is equal to 1. So we can say that e to the power of I times 2k pi to the power of x is equal to 2. All I did was substitute in that for 1. Now, if we solve for this, we should get our variable x. So what I'm going to do is I'm going to do the same thing I did the first time. I'm going to take the ln, or natural log, on both sides. So now I get ln of e to the power of I times 2k pi to the power of x is equal to 2. Now, if I have something in the form ln a to the power of b, this is equal to b times ln a. So I can move x to the front, and this is going to equal x times ln e to the power of I times 2k pi, which is equal to 2. Sorry, ln of 2. Now from here, this is the same thing as I times 2k pi times x times ln e, because I can again use the natural logarithm formula and bring this to the front. And this is equal to ln of 2. And if you guys already know, ln of e is simply equal to 1. So now I get I times 2k pi times x is equal to ln of 2. Now if I divide both sides by I times 2k pi, these two cancel out, and I get x is equal to ln 2 over I times 2k pi. Now I'm going to multiply both sides by I over I, which is equal to 1. So now I get x is equal to ln 2 times I over I times 2k pi times I. And I times I is I squared, and I squared is equal to negative 1. So now I get x is equal to negative I times ln of 2 over 2k pi. So this is my answer to this equation.